I remember when new releases of the compiler came out, a flurry of excitement, updating my dependencies, moving any patches that were necessary, making sure that every piece of OCaml software I'd ever written ran in that new version of the compiler. Going through that process, maybe a few days, get to the end of it. I would then delete the old compiler and just move forward. That was it. OCaml 308 is live. OCaml 307, ta-ta. Wind forward a little bit. That's not how we work today. There's still the excitement, there better still be the excitement with new releases of the compiler, but there's a considerably less of the deleting compilers that goes on. Modern development recommends that we sandbox our projects. So for opam, that's a local opam switch. And at present, for good or for ill, that means we need in some way to copy the compiler. On this machine here, compiling OCaml 414 under MSVC takes 7.5 minutes. It maxes the CPU's 8 threads for that time, and it runs the power supply to its maximum. So if I'm going to do it, I don't want to do it more than once. That's what we should be trying to deal with. So there's some existing approaches. Easy is the package manager for the Reason ecosystem, but it's also capable of driving, or it's a package manager and a build system. It's a sort of complicated system in that sense, but it's just as capable of being used for OCaml projects. It, by default, has a global cache on your system, and as a result with that, when you run first compiler, next compilers that you run is cloned immediately, and it's really stupendously fast. Has a slightly interesting way in which it does it. So it builds OCaml by ensuring that it has a fixed length prefix that's around 125 characters so that it doesn't blow the shebang line under Unix. And it then writes that into its central cache. Now, at this point, Easy does a completely different thing as a build system. It manipulates the environment. It's heavily inspired by Nix. But it does allow you to share these caches between machines. And when the cache is cloned, it goes through all of the files in the cache, having computed the new 125-line prefix for the machine it's on, and it does sed. And it works. It's an interesting trick, but it does work. It's very, very fast. Opam bin, on the other hand, which was demonstrated at the workshop in 2020, that works by patching the sources of packages instead. So rather than having to do binary replacements, it works by saying, we'll make sure that the compiler is in a ready state to be cloned, and it does it for other packages. At that point, the clone for a new switch is just a matter of copying the files from the old one, and it is similarly fast. So the problems with both of these two, as far as I'm concerned, is that this is something that the developers at the time referred to it as, so it's not me adding it. The easy hack is not something that we'd ever expect to be able to upstream. It's very easy specific, and that's not something that can live in the compiler. And in fact, the patches in opam bin, the way they're implemented, are also kind of opam specific. So they're not quite in a state that they could come up into the compiler either. So what do we need to do to be able to relocate the compiler? Well, every single executable we compile contains inside it the location of the standard library that produced that compiler. It's there in one of the modules in the runtime itself, so it makes it into every executable. That's clearly a problem. That's got to go. And there's another place as well that if you produce bytecode executables, there's that shebang line at the top, or it's part of the executable header on Windows. So we have these two places where this is problematic. At this point, I think it's instructive to wind back and have a look at how bytecode actually works. So I've got a profoundly simple program here. It prints the location of the standard library, which comes from OCaml's compiler libs, and it prints the current working directory, which comes from the Unix library. I compile that to bytecode and produce this file lock.byte. Then I run it. The first thing that happens is that the launcher stub needs to locate OCaml run. It then transfers control over to OCaml run. OCaml run then has to find the thing that actually called it, and that's not trivial either. It then loads it. Having done that, OCaml run then needs to locate the OCaml standard library in order to read a text file inside it called ld.conf, and that contains a list of directories that OCaml run can search to find the stub libraries that are required by the cstub libraries. So in this case, dll-unix.so that are required by the bytecode image. And it loads them. Finally, at this point, the program runs and the bytecode interpreter starts up. So those are all of the stages of launching a standard bytecode executable, and every single one of them is capable of failing. So the launcher may be unable to find the interpreter if it's been moved or deleted. You may find an interpreter and it's not the right interpreter and it will complain about the bytecode image that it's got. You may have circumvented the finding of ld.conf and found the wrong one, and you're looking at stub libraries or not even able to find stub libraries where that pointed to. Having loaded the stub libraries, they could be for a different version of OCaml and they fail to load. And even if you get to the end of this process, as we said before, this location that we're producing is fixed and we need that in some way to become relative. So there's a whole series of problems going on in here, and I'm going to risk a live demonstration of those on stock OCaml, which I think may require me to temporarily exit the slideshow. Yes. So here I have a series of OCaml compilers. They are in fact using the relocatable patches, but none of them are turned on. So this is effectively stock OCaml with some slightly different messages. I can put a little rune into the command processor and ask it to tell me the standard library location of all of those compilers. And you can see they're all working. It's just returning a directory. So I now go up one directory and rename it, and then go back in. And if I ask that to do exactly the same thing, chaos ensues. They all complain that they can't find their runtime. That message isn't actually the one you'd get now, but it's still the same effect. The runtime was not located. Even if I tell it to use the native compiled versions, as I said, each one of these is now returning the old location of the standard library, which doesn't exist anymore. So even the native code versions of these compilers are broken. So what can we do about this? Oops. Bring in native code. Link with -custom, link with -output complete exe. These are all solutions that exist to solve these problems. Well, native code does have just a couple of other uses. -custom and -output complete exe are slightly obscure. Well, in -custom, it's an old option in the compiler. -output complete exe is literally a workaround for this problem. They work by embedding the runtime and the stub libraries in the same executable, and so circumventing the first 4 of those problems. But crucially, none of them solve this issue about the standard library location. So we don't really have any answers for this. OCaml run at the moment works by finding the first ld.conf that it came across and loading it, and the launcher only looks for the OCaml run as its pre-configured location. So one of the things that I've emphasized about this work that I've done here is that the changes are simple. Unfortunately, that doesn't always correlate to the implementation being simple, but we could start looking for other ld.conf files. So in this case, there is an environment variable that overrides the predefined location of the standard library. So rather than just loading that, we can load them all in order, and we would get exactly the same semantic search path as we had before, just with the possibility that some things that didn't work might now work. And we can do the same thing with a bytecode executable launcher. We could search, if we can't find it at the pre-configured location, we can search the executables directory, or we can search path, and we can find OCaml run, and we can using these other search locations, find the stub libraries. Woohoo! Problem is that several of those failure modes are all about finding the wrong things. So searching is great, searching more locations is great, but the simple fact was that one of those failure modes was that the actual runtime being pointed to had been upgraded, or the Unix stub library for the wrong version. So what can we do about this? We could rename them. That's the profoundly simple part that came in it. If we introduce a naming for the internal library, so for OCaml run and for these stub libraries, that's based on the platform you're running on, based on the version and configuration of OCaml, nothing else actually changes in the runtime. We've got a big search path where we're searching for a very specific thing, where hopefully the other compilers that are now on the user's computers don't get in the way. And the crucial thing that's nice about this from my perspective is that it's invisible to the user. The user does not care about the names of shared library objects, and the user doesn't care about the name of OCaml run. It all just works. The only thing that has to care is Dune generating install files for it. That's all so far so good. We've still got to deal with that standard library problem. So ld.conf itself by default has absolute paths in it. That's dead easy to deal with. We just switch to using relative paths, and we interpret those relative paths relative to the file itself, because the directories it refers to will typically be within the same subdirectory as where the file was found. So that's a very easy change to make that clonable. We could do a similar trick for the standard library. When we install OCaml, the tools go into a bin directory. And by default, if you go up one level down into lib_ocaml, so /lib/ocaml, you will have found the standard library. And we can encode that. We just switch and put a little bit of code in to make sure we evaluate that correctly, especially with the bytecode launcher. It's not quite as simple as that. unfortunately. So there's a little bit more subtlety that comes into this because we need to know that we've definitely started from the right place. So the executables that we produce would also do this. And if they themselves happen to read the config library, they're now going to assume that from my working directory, there's one level up, there's then lib/ocaml containing a standard library, and they will still fail to work. So in fact, it turns out this is effectively a cross-compilation problem. What we need is the compiler to be doing this, where we know where it's going to be installed, and then the executables that the compiler produces not to do this, to use whatever was computed as the absolute location. So effectively, it is a host versus target issue, and that actually provides a quite useful intuition for the feature that's then added. The way this is then implemented in the compiler actually means it's possible to have executables that themselves could choose to opt into it. So tools that know they will be installed next to the compiler could also choose to locate the standard library this way, if that's as they need. It's also useful from a reproducible perspective, as well as a relocatable perspective. We'd like it to be that if you're looking at an opam switch, you cannot tell the difference between whether that compiler was compiled specifically for that prefix or was cloned from another prefix. I think that's a fairly obvious starting point. But we'd also like the same to be true of the executables that it produces. That the binaries that we get are exactly the same in each instance, however we got to the compiler. And it's that aspect, I think, makes the patches viable, hopefully, for upstreaming. So if we then put all of that together, we had the previous demonstration with this broken set of stock compilers. And if I go into here, we can see this is compiled with my set of patches for relocation, and this set of compilers clearly works. And then I can rename that. And running the same command, they now have, as you can see, hopefully, relocatable has changed the music.